this problem, a matrix A is given as 0, alpha, beta and 0, and is asking what will be the condition if A cube plus A is equals to 0. Now we know that A cube plus A is 0, so I'll write it as A cube is equals to minus I. Multiply A inverse on both sides, so it will be A square is equals to minus I. Now let us find out A square. 0 alpha beta 0, 0 alpha beta and 0. Now if I multiply, it will be alpha beta, then 0 alpha beta. Now this is nothing but A square, and which is equals to minus I, which is minus 1 0 0 minus 1. So clearly alpha beta must be equals to minus 1, which is option D. Problem, we have to find the limit of integral y to a e power sine square t dt plus a to x plus y e power sine square t dt by x. Now as the limit is from y to a and a to x plus y, I can write it as y to x plus y. So this can be written as limit extends to 0 integral over y to x plus y e power sine square t into dt by x. Now in order to find the limit of this expression, what I do is I'll use L'Hospital's rule. So I will differentiate numerator and denominator separately. Differentiation of a to b f of x dx is nothing but f of b into f dash of b minus f of a into f dash of a. So here b is nothing but x plus y, a is nothing but y. So if I substitute that value, it will be f of b is nothing but e power sine square of x plus y into differentiation of b. Differentiation of x plus y is 1 plus 0 minus differentiation f of a will be e power sine square y, and differentiation of y is nothing but 0 by differentiation of x is 1. So limit x is tending to 0. So I can write this as limit x tends to 0 e power sine square of x plus y. Now as x is tending to 0, this will be e power sine square y, which is nothing but option A. Differentiate the function y is equals to x power x plus x power 1 by x. Now we cannot differentiate this x power x and x power 1 by x directly, so I'll convert them into two different functions. I'll take x power x as y1 and x power 1 by x as y2, and I'll apply logarithm. Logarithm of y1 is x log x here, and logarithm of y2 is nothing but 1 by x log x. And I'll apply UV rule, that is product rule, and differentiate this, and I'll obtain the value of dy1 by dx as y into x power x into 1 plus log x. Similarly, dy2 by dx is nothing but x power 1 by x square into 1 minus log x, and their sum, which is differentiation of y, will be x power x into 1 plus log x plus x power 1 by x into 1 minus log x by x square, which is nothing but option A. This problem, it is given that a die has 4 blank faces and 2 faces marked as 3. So a die consists of 4 blank faces, only 2 faces are marked as 3. Now he is asking, if it is thrown for 5 times, what is the probability that you will get 12? Now we will get 12 if out of 5 throws, exactly 4 throws are 3's. So and 5th throw must not be 3, so it should be blank. So exactly 4, it is nothing but p of x is equals to 4. We'll use binomial theorem here, and the number of throws here are 5. See, and what do we need? We need exactly 4, and the probability of getting a 3 is nothing but 2 chances out of 6 chances raised to the power of 4 into, and not getting is nothing but 4 chances out of 6 chances. And if we simplify it, will be 5c4 into 1 by 3 raised to the power of 4 into 2 by 3, which is nothing but option A. To find the area bounded between the regions y square is equals to x and x square equals to y. We know y square is equals to x is a parabola symmetrical along positive x-axis, and x square is equals to y is a parabola symmetrical along y-axis, and both the curves will pass through origin. Now we have to find this area. In order to find the area, first we have to find the limits. That means solving these equations 1 and 2, either you can get the values of x or you can get the values of y. Now if I simplify these equations, we'll get the value of x as x0 and x1. So the limits are 0 to 1 as we are taking the limits as x, now we have to differentiate this y to get the area. So 0 to 1, y in the first case is nothing but root x, and in the second case is nothing but x square. If I integrate, it will be 2 by 3 into x power 3 by 2 minus x cube by 3 over the limits 0 to 1. And if I simplify, then the answer will be 1 by 3, which is nothing but option B.
Is subjected to a bending moment of 400 Newton meter and twisting moment of 300 Newton meter. The equivalent bending moment is. So when a shaft is subjected to both bending moment and twisting moment, equivalent bending moment is given by half of the m plus root of m square plus t square. So it gives, yeah, we know that the bending moment and twisting moment values, those are 400 plus root of 400 square plus 300 square, which gives a value of 450 Newton. So in the options, the right option is D. D is the right answer. The given stress condition, sigma x is equal to 2 Newton per mm square, sigma y is equal to 0 and tau xy is equal to 0. Which one of the following figures represents Mohr circle? So here there are 4 diagrams. So we'll have to find out the Mohr circle diagram. Which diagram represents Mohr circle diagram for the given stress condition? In the Mohr circle, normal stress taken on the x-axis and shear stress taken on the y-axis. Here there are two normal stresses, sigma x and sigma y, but sigma y is equal to 0 and sigma x is equal to 2 Newton per mm square, and shear stress also 0. When we consider on the Mohr circle, here tau xy is already 0 and sigma y is 0 and sigma x is some value that is 2 Newton per mm square. So Mohr circle now take center between these 2 points and draw a circle as a radius. As a radius, let us say this is O and this is A. OA as the radius and OA as the center, draw a circle which gives Mohr circle for the given stress condition, that is in the options D is the right answer. So the following theories of failure is suitable for ductile materials. Here are the options: Guess theory, Rankin's theory, and the option C is either A or B, and the option D is neither A nor B. So here Guess theory is nothing but the maximum shear stress theory, and it can be used for ductile materials. So the right option is A. And here Rankin's theory is nothing but the maximum principal stress theory, and it can be used for brittle materials. Law which relates the diameter of the rivet D and plate thickness T, that is D is equal to 6 root T, is suitable for. So here the right answer is T less than 8 mm. So this formula is suitable for the thickness of the plate less than 8 mm. Stress in the bar when the load is applied suddenly is dash times the stress induced due to the gradually applied load. Here the answer is 2 times. So the stress in the bar when the load is applied suddenly is 2 times the stress induced to the bar when the load is gradually applied. So the correct option is D.